In case of a solar panel, it is the maximum power it can produce under ideal standard test conditions. Typical ideal standard test conditions would mean solar irradiance or the intensity of sunlight of 1000 watts per square meter, photovoltaic cell temperature of 25 degrees centigrade, and an air mass of 1.5 g. The term 1.5 g refers to AM 1.5 g solar spectrum, which is a standard for testing terrestrial solar cells. 1.5 indicates that the light has traveled through a path length of about 1.5 times the possible shortest distance from Sun to Earth. G stands for global, meaning that it includes both direct and diffuse or scattered light. AM0 will be corresponding value in space beyond the atmosphere. AM 1.5 corresponds to sunlight received at an angle of 48.2 degrees from the zenith. It represents the yearly average irradiance from Sun in temperate or mid-latitudes where many large population centers are located. Though that is the peak power output at standard test conditions, actual performance can vary significantly. Temperature may be much higher than 25 degrees, which reduces the efficiency. Rooftop solar panels in this region with hot climate are usually kept elevated above the roof to give good ventilation below the panels. That will reduce the rise in temperature of the solar panels while in bright sunlight. Shading from clouds, trees and buildings can decrease the power output of solar panels. Tilt of the solar panel relative to the direction of the sun will also affect the power generated. Even in a specific location, this will vary from season to season and throughout the day. Dirt and debris accumulated on the surface of panels can block solar irradiation and hence reduce power production, mandating periodic cleaning. Sun tracking solar panels can improve the energy production. It has been in use by some of my amateur radio friends, including VO2 Mike India Echo in Wayanad. One ham from overseas posted seeing a whole solar field with sun tracking systems in Germany. VO2 XPZ mentioned that engineering student projects with couple of light dependent resistors have been used for sun tracking solar panel systems. Higher grade of control is possible with microcontrollers like Arduino as well.